Hi friends, here is a very nice problem that came in JEE Advanced 2017. This one is about counting number of matrices. This involves matrices also, this involves counting principles also, permutations also, and as well as matrices. How many 3 by 3 matrices with entries 0, 1, 2? The matrix, each matrix can have 0 elements has 0, 1, 2 only, nothing else. 3, 4, 5, those kind of numbers are not permissible. All the entries in the matrix 3 by 3, all the 9 elements are 0, 1, or 2. Right? Are there for which sum of the diagonal entries of M transpose into M is 5. Right. There is a 3 by 3 matrix and transpose of that times that original matrix, there will be some diagonals, right? This one will lead to another 3 by 3 matrix. The diagonals of that, sum of those diagonals is equal to 5. Right. Obviously, M and M transpose both are made with elements of 0, 1. Right. Then how many such matrices are there? Right. First, let us take a random matrix M and see how its transpose is and what is the product of M transpose into M. Right. For example, let's take this matrix M. Let's take a matrix M, which is A, B, C, D, E, F, G, H, I. Right, and let's do the transpose of this. What is the transpose of a matrix? It is rows will convert to columns and columns will convert to rows. For example, the first column will become first row here. A, B, C will go here, A, B, C. D, E, F will go here, D, E, F. First, second column will become second row. And G, H, I, third column will become third row. Right. So GHI. This is M transpose. Now let us do the multiplication of M transpose and M. So what is the multiplication? This ABC into this ABC. Right. That is A square plus B square plus C square. That is the first element. Then this one ABC into DEF. Right. That is ADBECF. Then ABC into GHI. ABCGHI. Similarly, DEF into ABC. DEF ABC. Right. DAEF, DAEB, FC. Similarly, DEF into DF. D square, E square, F square. DEF into GHI. DGEH, DEF, GHI. Right. GHI into ABC. GHI, ABC. GHI into DEF. GHI, DEF. GHI into GHI, G square, H square, I square. We are concerned about only the diagonal integers. Alright. What is the question? The question is that the sum of diagonal entries of this resultant matrix of this matrix is 5. That means A square plus B square plus E square plus D square plus E square plus F square plus G square plus H square plus I square. Basically, the original sum of 9 elements. Squares of the original 9 elements. Right? The squares of original 9 elements, sum of squares of original 9 elements should be equal to 5. But we are given one more condition. The condition is all entries are 0, 1 and 2. So that means A, B, C, D, E, F, whatever, all this can be 0 or 1 or 2. Right. Now we have to find A, B, C such that all the sum of squares of all of this is equal to 5. Right. We have 0, 1, 2. 0, 1, 2. Obviously there are only two ways. Right. A square, let's say any one of this. We have to create some 5 using squares of 0, 1, 2. Obviously, there are only two ways. One is 2 square plus 1 square, which is equal to 5. We cannot have two 2's, right? Because 2 square plus 2 square, which is 8, which is greater than 5. So there can be only one 2. This is one way. Or otherwise, the second way is take all ones. 1 square plus 1 square plus 1 square plus 1 square plus 1 square is equal to 5. Right? 2 and 1 remaining zeros, or take all 5 ones. There is no other option. Right? Because the elements are 0, 1, 2. Right? Either we can have 1, 2 and 1, 1 and remaining zeros. That is 7 zeros. 1, 2, 1, 1 and 7 zeros, or 5 ones and 4 zeros. Right? Clearly, we cannot have more than 1, 2. Right. Now, what is this? These are 9 letters. This is equal to creating 9 letters, arrangements of 9 letters, where one letter is 2, one letter is 1, and 7 are zeros. Right. This will this will lead to how many permutations of this common, this set, right? 2 square plus 1 square equals 5, right? 1, 2, 1, 1, and 7 zeros, total 9 letters we have. How many arrangements are there? It is 9 factorial by 1 factorial into 1 factorial into 7 factorial. Basically, it is 9 into 8, which is 72. When we have 1, 2, and 1, 1. When we have 5 ones and 4 zeros. Again, 9 letter arrangement, 5 ones and 4 zeros. Right. So how many arrangements will be there? 9 factorial by 5 factorial into 4 factorial. So 9 into 8 into 7 into 6 by 4 into 3 into 2 into 1. Right. 5 factorial we are removing. 4 into 3 into 2 into 1. So here this will become 9 into 7 into 2. Right. 4 3 into 2 we can cancel with 6 and 4 goes 2 times in 8. So this becomes 126. So the total arrangements are this 72 plus 126, which is 198. Right guys, please note this one. When there are 9 letters of which 5 are same and 4 are same, then the total arrangements is 9 factorial by 5 factorial into 4 factorial. Right, for example, in 9 letters, all 9 are same, then what will happen? Let's say all 9 are zeros or all 9 are ones. Then what will happen? There is only one way, right? That is equal to 9 factorial by 9 factorial, right? If 9 factorial all are different, right? All 9 letters are different. Then how many arrangements will be there? It is 9 factorial, right? 9 factorial by that is equal to saying 9 factorial by 1 factorial into 1 factorial into 1 factorial, what likewise, right? When in 9 letters, 5 are same, 4 are same, then the number of arrangements will be 9 factorial by 5 factorial into 4 factorial. Right, guys? It's a very simple problem. Just that we should not get worried by looking at matrices and permutations together. We just need to worry about take one random matrix of 3 by 3 entry and see what is happening to M transpose into M and look at the diagonals. It is just sum of squares of all entries, all 9 elements of the matrix. Right, yes. Hope you like this. Thank you.